Hello everyone, this is Pavan Kumar, and today we will start our chapter number 3, uh, chapter number 3 of physics class 12th. Okay, so this chapter 3 is current electricity. In the previous chapters, we studied about those facts and phenomena which are related to the charge, but when the charge is stationary, when charge is in the stationary form. But here in the chapter 3, we will be studying all those facts which are related to the motion of charge, right? So, what is related to the motion of charge? You know that whenever charge moves from one place to another place, what you can say, what can produce? What could be produced? Electric current will produce. So, this is only our first topic. What is our first topic? Our first topic is electric current. Okay, electric current. What is electric current? Electric current is, wait, electric current. Electric current is the flow of flow of charge. Flow of charge per unit time. Per unit time. This only we studied about electric current. How we can say this? We know that the formula of current is I is equals to Q upon T. When T will be equal to 1 second, then we can define electric current in terms of charge. And how can we define? That electric current is the amount of charge flowing per unit time. Or you can say in other words, rate of flow of charge. Rate of flow of charge. You can say this is also called electric current. These are all basic things which you have studied in lower classes. Now let us move back to our book. In our book, see, first topic is electric current only. Now, after this, you can see the formula I is equals to Q upon T. Now, what is another important thing? Another important thing is formula of current only. Suppose if we are taking time interval less than means very less, that means time interval which tends to 0. In that case, what will be current? Current will be limit delta t tends to 0 delta q upon delta t. And you know, whenever we are writing in terms of limit like this, when delta t tends to 0, I can also write in that case like this. I is equals to dq. I is equals to dq upon dt. I can write dq upon dt. I hope you have studied these things in mathematics, or if not in mathematics, in physics you have studied in class 11th. So I don't think you will be having problem in writing this formula. After this, what do you have? Electric current in conductors. How current flows in conductor? This we have to study here. Suppose children, this is a part of conductor. Okay, in conductors we know that electrons are free to move here and there. So suppose when to this conductor no battery is connected. Battery means, suppose if I am saying that to a conductor there is no battery connected, then you by this you understand that there is no electric field applied. Okay, whenever I say there is no battery connected, you understand it in this way that no electric field is applied, because electric field we will be applying by connecting a battery. As you know that battery has one positive and one negative terminal, and the electric field lies from positive to negative only. So whenever battery will come, then only electric field will be produced, otherwise there will be no electric field. So in case of absence of electric field, what you see that in conductor electrons still they are free to move, but they move in random direction. They move in random direction. This motion in random direction is due to the thermal energy received by the electrons at room temperature. Okay, now we studied whenever there is motion of charge, it constitutes some electric current. That means all the electrons must be producing some current. But if you will look the direction of these electrons, then you will see the direction is random. Direction is random means when you will find out the average of all these currents, then what you will get? You will get net current equal to 0. Net current equal to 0. That's why we say that that if you have not connected any battery through any conductor, till then no electric current will flow. Even we know that there is motion of electrons, free electrons in conductor, which always taking place. So this is all about electrons and flow of electrons and electric current inside conductors. Now let us move to our book. What is the next topic after this? After this we have, you can see this is the conductor. You can see the direction of electric field. This direction of electric field will be induced if you will connect positive terminal here and negative terminal here on this side, right? After this, you also studied about resistance. You studied about resistance in class 10th. What is resistance? Resistance, by resistance you study, you come to know that it is opposition. What is it? It is opposition. It is opposition to the flow of current. It is opposition to the flow of current. Okay, opposition to the flow of current, right? And there were various factors which we studied on which the value of resistance depends. Okay, so what are all those factors? Let us see them here. Resistance, we studied that it will be proportional to length of the conductor. Resistance will be inversely proportional to the area of conductor. Resistance will be temperature dependent, and resistance will be dependent on the nature of material. Nature of material. On all these factors resistance depends, right? So what you can say, that if any of the factor will change, the value of resistance will also change. Okay, so after this, what we have, the next topic is Ohm's law. Next topic is Ohm's law. What is Ohm's law, children? What is Ohm's law? Ohm's law is nothing but the relationship between current and voltage. Relationship between current and voltage. Voltage you studied in second chapter. Current you studied here. Between them there is a relationship which says that I will be proportional to V. That means if you increase V, I will increase. If you decrease V, I will also decrease, right? This only we studied. Now if I is proportional to V, then it will be under some conditions. What are those conditions? Physical conditions. When physical conditions remain unchanged, or you can say when physical conditions remain constant, this is known as Ohm's law. Okay, what is Ohm's law? In Ohm's law we study that electric current is directly proportional to the potential difference applied, keeping physical conditions constant like temperature, pressure, etc. Okay, all these things, because we know that if temperature will change, the resistance of the conductor will change, and if the resistance of conductor will change, there will be no proportionality of I on V. Since we studied that I is proportional to V, okay, then I can say that what can I say? I can say that one will be proportional to V upon I. I can say after cross multiplying. Now if you remove this proportionality sign, a constant will come, and that constant will be R. That constant will be R. Okay, what is this R here? R is nothing but the resistance about which we talked just few minutes ago, right? So this is resistance. R is equals to V upon I. And when you cross multiply, you obtain one formula of potential difference, which is given by V is equals to IR. Okay, after this, if you draw a graph, between V and I, if you draw a graph between V and I for a conductor, you know what type of graph will come out from this relationship? Because I is directly proportional to V. Because I is directly proportional to V, and between them only we are making a graph, then that means there will be a straight line which will be drawn between V and I. A straight line graph will be obtained. This was all about Ohm's law. Now, what is our next topic in the book? Let us see. Okay, the next topic I think will be the factors on which resistance depends. Yes, exactly. These are the factors on which resistance depend. We studied this Ohm's law in class 10th. Why we are studying it again? Because we want to find out vector form of Ohm's law. Okay, before vector form of Ohm's law, let us study something different. What different? Units. Unit of current is ampere, right? Unit of current is ampere, denoted by A. Unit of potential difference is volt, denoted by V. What is unit of resistance? Unit of resistance is ohm, and its symbol, its symbol is like this. Now, if you want to define 1 ohm here, how can you define? You can define with the help of formula of resistance. R is equals to V upon I. R will be 1 ohm when potential difference is 1 volt and current is 1 ampere. So how can you define this? You can define it like this. When 1 volt of potential difference is applied, or you can say like this, if 1 volt of potential difference applied and 1 ampere current flows, then the resistance of conductor is 1 ohm. In your own language you can make definition. Okay, once again I am repeating, if after applying 1 volt potential difference 1 ampere current flows through conductor, then the resistance of conductor will be 1 ohm. Okay, this is about unit and the definition of 1 ohm. These all things we studied in this